Here is an example of a question which should be about number 5 out of 25 on an AMC 8. We have a sequence of numbers, 1, 3, 5. Do you know any sequences of numbers, 1, 3, 5? 1, 3, 5, 7, 9, 11, and so on. But it's not that one. This is one which is based on a method called recursion, where the next number is based on the previous numbers. The next number here is always the sum of the previous 3 numbers. For example, if you see 1, 3, 5, the next number is 1 plus 3 plus 5, which is 9. What is the 8th number? When you see this kind of question, and you're only supposed to find the 8th number, to be honest, just go. Try to do it quickly, and try not to make a mistake. We'll talk a bit about the methods to not make that mistake. But the thing is that 8th is not far, so there's not actually that much work to do. My philosophy here is if I know what I will have to do to finish, the moment I know that there's not that much work to do, then you can go. Okay, so let me say what the numbers are. 1, 3, 5, and the next one is the sum of those 3. 1 plus 3 plus 5 is 9. Then the next one is supposed to be 3 plus 5 plus 9. 3 plus 5 is 8. 8, 9, 17. Okay, now I need to take 5 plus 9 plus 17. Maybe this is mental math now. 5 plus 9 is 14. 14 plus 17 is 31. I'm able to do these because these numbers are my friends. And if you have seen 4 and 7, 4 and 7 is 11, and if extra ones. Okay, let's keep going. I need to get 8 numbers all together. 9, 17, and 31. 9 plus 17 is 26. 26 plus 31 is 57. At this point, I want to be a little bit careful because it's very easy to make mistakes. I've added so many things together. If I wanted to check, I see a 7, there was a 7. I ask myself, is it reasonable that there's a 7? And I say yes, because 9 and 1 was 10. Okay, keep going. So far I have 1, 2, 3, 4, 5, 6, 7. I just have to make the last number. So I just need to add these 3. At this point, if I know I just need to add these 3, let's just add these 3 the normal way. Add, and remember that we're only adding these 3. And if we add these 3 at the end, 7, 7, 14, 1, 15, and then 1, 1, 3, that's 5 plus 5, 10. 105 is the answer. Okay, but at this point, I'm actually very scared. Did I make a mistake? Whenever you do this kind of question, it's actually very common to make a mistake. So let me show you another way to do this. Another way to do this, which actually might even be easier. So the other way I'm going to say is that maybe let's not think of 1, 3, 5 yet. Let's call them A, B, and C. I have A, B, and C. In that case, can you tell me what's the 4th number? Well, that's easy. That's just A plus B plus C. I don't even have to do any work. Of course it's A plus B plus C. What's the 5th number? I need to take these add together. B plus C plus A plus B plus C. Do you see that all we're doing now is we're counting how many A's, B's, and C's we have? So let's see. I'll have 1 of the A's, 2 of the B's, and 2 of the C's. That's what I get when I add these 3. Oh, then how do I add these 3 to get this one? I can now look at it this way, and I say, if I add them together, I'll have 2 A's, 2 A's, 3 B's, and 4 C's. Okay? And so far I have this. I have 2 more to go. To continue, I now need to add this stack of 3 things together. That gives me 4 A's. I have 6 B's. 1, 2, 3 are my friends. 1 plus 2 plus 3 is 6. 1, 2, 4. Actually, that's also my friends. 1 plus 2 plus 4 is 7. Those are powers of 2. And let's finish at the end. If I add all these together, at the end, I will have 7A plus 11B plus, here I have 13C. And now let's put everything together and check. If I was to multiply these together, 7 A's are just 7. 11 B's are 33. And I need 13 C's, which is 65. 5 times 13 is 65. Okay? I often know this because 5 times 12 is the number of minutes in an hour, if you look at a clock. And so 5 times 13 is the next. Add these together. 7, 3 is 10. So 15. And 1, 3, 6. 105. Good. So the answer is correct. But I did this way on purpose because I want to use this to introduce for you an even another way to think about this. Look, when I drew this down here, I just was writing lots of A, B, C. Wouldn't it be easier if I just knew that the A's would always be the first column, the B's are always the second column, and the C's are always the third column? So let me give you another way. I will say here's A, B, and C. And now I'm just going to keep track of how many there are in each column. So for example, it starts with 1A, 0 B's, and 0 C's, then 0 A's, 1 B, 0 C's, and then 0 A's, 0 B's, and 0 C's. Each of these rows corresponds. Now the next row is just the sum of the 3 previous rows. So 1, 0, 0 is 1, 1, and 1. And then the next one, if I add the 3 previous rows, I get 1, 2, and 2. Look, these are just the same numbers, just without A, B, C. It's faster. And if I just keep going, you even find out I don't even need to do them row by row. I can do them by the column and say 0 plus 1 plus 1 is 2. And then 1 plus 1 plus 2 is 4. 1 plus 2 plus 4 is 7. 0, 1, 2 adds to 3. 1, 2, 3 is 6. 2, 3, 6 is, in this case, 11. 1, 1, 2 is 4. 1, 2, 4 is 7. 2, 4, 7 is 13. And I have all the numbers again. I'm actually not going to tell you that this is always faster than that. Actually, in some sense, this is 3 times as slow as that, because I need to do the same thing 3 times. Why I'm showing you this is for a different reason. It's because when you're doing these problems, a number 105 is scary. You don't know if you made a mistake. If you have 2 ways that are very different, even if one is actually maybe even slower, if you do it 2 ways and get the same answer, very different ways, then you're sure it's right. But the second reason I showed you this is that you will see this idea later in high school, in algebra, or in linear algebra. This is the concept of a matrix, which is actually how you solve equations when you have many, many unknowns. This idea that you will have the same letter in the same place, so you only write the number, is an idea that will be very, very important for you in high school and college math. But you've seen it here first.